So here we have 2 points A and B and the coordinates are given to us. We need to determine the coordinate of the third point P with the condition that PA equals PB. That means the length of PA equals the length of PB. And also the area of the triangle that is formed by joining the 3 points equals 10 square units. Let's try to first understand the problem graphically. So here we have 2 points, point A and point B. So here point A, let's say it has the coordinates 3, 4 and B has the coordinates 5, -2. Now we have a third point P. So we are going to name its coordinate as x, y. So let the third point be x, y. Now the point P is chosen in such a way such that the length of PA that's going to be equals to the length of PB. So let's join PA and we are also going to join PB. Now we can easily find out the length PA and also the length PB by using what is known as the distance formula. So let's apply the distance formula to find out the length of PA. So first we'll take the square root. So underneath the square root, what we'll have to do is take the difference of the x coordinate. We square it and then add it to the difference of the y coordinate and square that value. So what's the difference of the x coordinate? So here the x coordinate of P is x and the x coordinate of A is 3. So here the difference will be x minus 3. And then we come to the difference of the y coordinate. So the y coordinate of P, that's y, and y coordinate of A, that's 4. So our difference will be y minus 4. So this must be equals to the distance of length PB. So here also we can apply the distance formula. So for PB, the difference of the x coordinate, that's going to be x minus 5. So we're going to square this value and add it to the square of the difference of the y coordinate. So the difference of the y coordinate will be y minus -2. So that means we have y plus 2 whole square. Let's square both sides. This is going to get rid of the square root. So we have x minus 3 whole square plus y minus 4 whole square. And this value will be equals to x minus 5 whole square plus y plus 2 whole square. Now what we'll do? We will expand x minus 3 whole squared, y minus 4 whole squared, and also x minus 5 whole squared and y plus 2 whole squared. So x minus 3 whole squared, this expansion is going to be x squared minus 6x plus 9. Added to the expansion of y minus 4 whole squared, so that's going to be y squared minus 8y plus 16. So this will be equals to the expansion of x minus 5 whole squared, so that's x squared minus 10x plus 25. So this will be added to the expansion of y plus 2 whole squared, so that's y squared plus 4y plus 4. Now what we can do, we can cancel out x squared from both sides, and we can also cancel out y squared from both sides, and whatever is remain, let's combine them. So here we have negative 6x, so we'll transpose this negative 10x from the right hand side to the left hand side. So on the left hand side we will be left with 10x minus 6x, that's going to be 4x. Then we have negative 8y, and on the right hand side we have positive 4y. If we transpose it to the left hand side, so we're going to get negative 8, negative 4, so that's going to be negative 12y. So the x, y's are taken care of. Now we will combine the constant term. So 16 plus 9, that's going to be 25. So here we can cancel out the 25 from both sides, and now we're only left with 4. So 4x minus 12y, so that's one equation that we have. Now what we can do, we can factor out 4 from both sides, and that leaves us with x minus 3y equals to 1. So we're going to name this as equation number 1. Fine. So this is a relationship between x and y that we have obtained. Now it's given here that if we join, let's say, point A and point B, we're going to get a triangle PAB. So here we have a triangle PAB, and this area of this particular triangle is given as 10 square units. So we're going to use this fact to obtain the coordinate of point P. If we know the coordinates of the 3 vertices of a triangle, so let's say they are x1, y1, x2, y2, and x3, y3, then the area of the triangle is given by this expression, half times the absolute value of x1 multiplied to y2 minus y3, added to x2 times y3 minus y1, plus x3 times y1 minus y3. So in our case, we have the triangle ABP, and in this triangle is given here that the area is 10 square units and the coordinates of the vertices are known. So here let's use this particular formula. So we will have 10. So that's the area. This will be equals to half times the absolute value. So now we need the vertices in terms of x1, y1, x2, y2, and x3, y3. So let's do one thing. Let's make an assumption here that P is equivalent to x1, y1. Let's say A is equivalent to x2, y2. And then B is x3, y3. The other way we have chosen is completely independent of choice. So you can choose whichever way you want. That means you could have started with A as x1, y1, B as x2, y2, and P as x3, y3, and you're still going to get the same result. Fine. So let's begin. So here we need x1. So x1 is corresponding to x. So we have x multiplied to it will be y2 minus y3. So here y2, that corresponds to the y coordinate of A, which is 4. And from here, we're going to subtract y3. So that y3 is the y coordinate of B. So that's negative 2. Since we're subtracting, we're going to get negative of negative 2. So that makes it positive. So we have x times 4 plus 2. Moving on to x2. So here x2 corresponds to 3. So we have 3 multiplied to, we need y3 minus y1. So here y3, that's negative 2. And y1, that corresponds to y. So we have negative 2 minus y. Added to, now we need x3. So here x3, that corresponds to 5. Where 5 multiplied to, we need y1 minus y2. So y1, that corresponds to y. And from here, we're going to subtract the value of y2. So y2, which is the y coordinate of A, that's simply 4. Fine. So we now get, so let's multiply both sides with 2. So we get 20 equals to the absolute value. So 4 plus 2, that's 6. 6 times x will be 6x. Then we multiply 3 with negative 2 minus y. We'll get negative 6 minus negative 3y. Then 5 times y minus 4, so that's going to be plus 5y minus 5 times 4, that's 20. Fine. So we have 20 equals to 6x. So 5y minus 3y, that's positive 2y. Minus 6 minus 20, so that's 26. Fine. Now, what we can do, we can replace the value of y. So here, let's use equation number 1. So from equation number 1, if we isolate x, then x will be equals to 3y plus 1. So what we'll do, we'll replace the value of x with 3y plus 1. So let's do that here. So we have 20, that will be equals to absolute value of 6 times x. So x will be replaced with 3y plus 1. So that's going to actually help us find out the value of y. Plus 2y minus 26. Then we have 20 equals to 6 times 3y will be 18y plus 6 plus 2y minus 26. Right, so we have 20 equals to, so 18y plus 2y, so that's 20y. 6 minus 26, so that's negative 20. Fine. Now what we can do, we can use this equation. So let's use it here. So we got absolute value of 20y minus 20. We got this value equals to 20. Now there are two possibilities. One of the possibility being we get 20y minus 20 equals to positive 20. So this is one of the possibility. Or we could get the other possibility, 20y minus 20, that could be negative 20. So that means we now have 20y equals to, so 20, this is transposed to the right hand side and combines with positive 20 to make it positive 40. So y will be equals to 2. Or we have 20y equals to 0. So y could be equals to 0. So now we have two possibilities for y. Y could be either 2 or y could be 0. And since we already have the relation x equals to 3y plus 1, so we can use it to obtain the value of x. So using x equals to 3y plus 1. So that means when our y value equals to 2, this implies that x value will be equals to, so we have 3 multiplied to 2 plus 1. So 3 times 2, that's 6. 6 added to 1, that's going to be 7. So that means x comma y corresponds to the value 7 comma 2. Or the other possibility could be, so when y value is 0, then our x value will be equals to, we have 3 times 0. This will be added to 1. So 3 times 0 is simply 0. So we have x equals to 1. So that means we get the other possibility x comma y, that could be 1 comma 0. So this is the coordinate of point P. Thus, the coordinate of point P will be, so we have one possibility 7 comma 2, or the other possibility which is simply 1 comma 0.